Hello everyone, welcome back to IB Methodology, your space for mastering IBDP mathematics. In today's video, we will be solving May 2025 paper 1. This is a non-calculator paper, so I will be focusing on correct mathematical reasoning, clear algebraic steps and exam-ready presentation that helps you maximize marks. So let's begin with question 1. Now in this question, log 2 is given to us as P and log 3 is given to us as Q. We have to find an expression for log 24 in terms of P and Q. So let's start with A part. So first of all, we have to apply correct applications of log, which I can write as, if I have log xy with base 10, I can write it as log x plus log y. Both will be having base 10. So before that, I have to first factorize this 24. So I can write it as 8 into 3. Now I can apply the above property and I can write it as log 8 plus log 3, both with base 10. Now before moving forward, I have to again factorize log 8 as 2 cube. And now I have to apply the property, another property of log. If I have log x to the power m with any base, I can write it as m log x with base a. So if I apply this property over here, so I can write it as 3 log 2 with base 10. And I can simplify this step. I will write it here. So log 24 with base 10 can be written as 3 log 2 with base 10 plus log 3 with base 10. And in the question, log 2 is given to me as P and log 3 is given to me as Q. So this will be my final answer. Now to solve B part, I have to find an expression for log 8 with base 3 in terms of again P and Q. So before writing it, I have to first change the base. So if I want to change the base to 10, I can write it as log 8 upon log 3 with base 10. And since here I have already solved log 8 as 3 log 2, which I can use it over here and I can write it as 3 log 2 again with base 10 upon log 3 with base 10 remains as it is. So I can write this as 3p over q. Now let's move to the next question. In this question, this is the graph of y is equals to fx, where x is between minus 6 to 5. We have to write down the value of f of minus 3. So if we see, f of minus 3 means my x input is minus 3 and with respect to minus 3, I have to write my y value. So my y value will become minus 1, as you can see this in the graph. Now for the B part, it says state the domain of f inverse, where f inverse is the inverse of the function. So before finding the domain of f inverse, we have to remember that range of fx is domain of f inverse x. That we have to keep in mind. So now in the question, if you see, range of fx is that comes on my y-axis, y values. So I am maximum going to 5 and minimum I am going to minus 3. So I can write it like this. Minus 3 to my x goes to 5. It means this is my domain of f inverse x. Now for the C part, it says find the value of x which satisfied this. So I will first write this function, that is minus 3. I can take that inverse over there and I can write like this. Now f of minus 3 value from A part, I can write this value as minus 1. Now I just need to simplify this. So 2x is equals to 6, x is equals to 3. So I got my value of x as 3. Now in this question we have to solve the equation this, where my theta belongs from pi to 2 pi. Solving equation means we have to find the value of theta. So if you see in your formula booklet, you can use double angle identity of cos 2 theta as 2 cos square theta minus 1. Now why I am using 2 cos square theta? Because I have equation in cos only. Now I will be substituting this. So 2 cos square theta minus 1 minus 5 cos theta plus 2 is equals to 0. Now I will just simplify the equation. 5 cos theta plus 2 is equals to 0. So I got my equation as 4 cos square theta minus 5 cos theta is equals to 0. I can take cos theta common, so that become 4 cos theta minus 5 is equals to 0. It means either my cos theta is 0 or 4 cos theta minus 5 is equals to 0. Now since the interval given to me is between pi to 2 pi, so my cos theta is 0 means theta is 3 pi by 2. I cannot take pi by 2 value, so I have to consider this. Now from this I can write cos theta as 5 by 4, which is 1.25, which is exceeding the range for cos theta. So we will not accept this value. So my answer will be theta is 3 pi by 2. Now in this question we have a curve equation and a line equation. It says show that the curve and the line meet when this. Meet means both will have same y value. So for A part I can equate both y values. So I can write x square minus x minus 1 as mx minus 3, and now I just need to simplify this. So I am bringing everything to left side. Now I can take x common, that will be m plus 1 plus 2 is equals to 0. This is what we have to show in A part. Now for B part it says find the values of m where the line is tangent to the curve. Now there are two methods to solve this equation. I will solve by both the methods. So if I am talking about method 1, in method 1 I can use my discriminant formula, which should be equals to 0, means b square minus 4ac should be equals to 0. Now b value is minus m plus 1 minus 4, a is 1, c is 2. So I can write it as m plus 1 whole square minus 8 is equals to 0, which gives me equals to 8. So I can further write it as m plus 1 as root 8. So m plus 1 is plus minus 2 root 2. So final m value is plus minus 2 root 2 minus 1. So this is my m value. Now if you want to use the second method, since in the question it says tangent, so I can find dy by dx, that is derivative. So when you will find dy by dx of the equation, you will get 2x minus, and constant derivative is 0. Now if I put it equals to 0, my 2x value is coming as 1 plus m. It means m value is 2x minus 1. Now I have to substitute this value, substitute m value in A part to find x. Now how will I substitute? Instead of m I will write this, and it was m plus 1 plus 2 is equals to 0. Since first part answer was m plus 1x plus 2 is equals to, this was first part answer. So if I will simplify this, that becomes minus 2x square plus 2 is equals to 0. That is minus x square plus 2 is equals to 0, which gives me x square as 2, x as plus minus root 2. Now my m value was 2x plus 1 and I have to find m only. So I will substitute this in m. I will get root 2 minus 1. I have to write plus minus also, which gives me answer as plus minus 2 root 2 minus 1. So you can solve the question by any of the method. In this question we have two random variables x and y which are normally distributed as this. Now we have to find b such that probability of x greater than b is equals to probability of y greater than 22. So let's start with the solution. So we have to standardize both the probabilities. First I will do it for y. For y, probability of y greater than 22 means probability of z greater than 22 minus 19 by a, that I can write again as greater than 3 by a. Now if I want to write for x, so probability of x greater than b is nothing but probability of z greater than b minus 7 by a. Now if I will equate both the probabilities, so I can say that b minus 7 by a is equals to 3 by a. A will get cancelled out and b will be equals to 10. So this is how I will get my b value. Now in the b part, write down the approximate value of this. Correct your answer to two significant figures. Now how I will start? For this, from normal table, first I will copy what question is saying, x less than 7 plus a. Now from normal table, I can write this as minus 1 to 1, and from the table you can see this as 0.68. Now C part of the question was, it was given to us that a is equals to 3. We have to calculate approximate value of probability of y less than 22, and it should be correct to two significant figures. Now for C part, probability of y less than 22 is nothing but 22 minus 19 by 3, which is 3 by 3, which is 1. It means probability of y less than 22 or probability of z less than 1 is approximately 0.8413. So my final answer with two significant figures will be equals to 0.84. You have to leave your answer in two significant figures. Now in this question we have been given with a graph where we have local minima at a and local maxima at a and local minima at b, and the vertical asymptote is at minus half, and we also have an oblique asymptote which you can see in dotted line, 5x plus 5. Now we have to first understand, whenever we are talking about asymptotes, it always is in dotted line. You can never draw a solid line. Your marks will be deducted for it. Now in A part, on the following grid, we have to sketch the graph of y equals to modulus fx, indicating any asymptote. Now in this A part, I have pasted the solution of this modulus fx curve, where you can see that the asymptote, vertical asymptote half is the same. So we have to draw half, vertical asymptote passing through half. Also oblique asymptote is again the same, but the difference will be with this local minima. Now we cannot draw anything with negative x or negative y because we are talking about modulus fx. So in our graph everything has to be in positive. That's why you can see that in this graph has been drawn. Now in B part we have to sketch the graph of y equals 15 upon fx, indicating any asymptotes and intercepts with the axis. Now I have drawn the graph over here. So we have to make sure that we show all axis intercept. You can see one axis intercept over here, and since at half x is equals to minus 1 by 2, we had the asymptote. That's why it is drawn in open circle. It means this value is not included. And we have to include local extremas also. So this is how we will be drawing the graph. Now in this question, the curve x square plus y to the power 4 equals r square is given. We have to find an expression for the volume of solid in the form a pi r to the power v. So let's start with the solution. First of all, I will copy the equation given to me. So I can write my x square value as r to the power 4 minus y to the power 4. Now using volume formula, I can write pi x square dy, where my values are ranging from a to b. This you can see from your formula booklet. So for me, the limits will be minus r to r pi. I will be replacing x square value from here, r to the power 4 minus y to the power 4 dy, or I can write this volume as, I can take pi common. And why I am writing 2? Because I have changed my limits from minus r to r to 0 to r. So I can write this like this. Now you can solve from any which way. I will be solving with this minus r to r. So if I integrate, it will be pi r to the power 4y minus y to the power 5 by 5, since r to the power 4 will be a constant and my limits are from minus r to r. Now if I will put my limit, so it's always upper limit minus lower limit. So upper limit, if I put y as r, it will be r to the power 5 minus r to the power 5 upon 5. This is my upper limit, minus my lower limit will be minus becomes plus. Now if you will solve this, it will be 2r to the power 5 minus 2r to the power 5 upon 5, where I can take LCM 5, that becomes 10r to the power 5 minus 2r to the power 5. So volume will be 8 pi r to the power 5 over 5. Now if I compare this with what is given to me in the question is this. Now if we'll compare these two, this with this expression, so I can write as my a value as 8 by 5 and b value as 5. So we have found out an expression. Now in this question, we have a complex number z1 as root 3 minus 3i. We have to express this in r e to the power I theta. So to express this, first we have to find the modulus. So in general, if you have a complex number in this form, so its modulus is under root x square plus y square, and its angle or argument is tan inverse y by x. So now if I take z1 as root 3 minus 3i, so I can write modulus z1 as under root x is root 3 plus y is minus 3. On simplifying this, I will get root 12 or 2 root 3. Now if I talk about argument, that is tan inverse minus 3 by root 3, which is nothing but tan inverse minus root 3, which is pi by 3 with the negative sign. You have to remember this negative sign. So now if I want to write z1 in r e to the power I theta form, I can write it as 2 root 3 e to the power minus I pi by 3. So this becomes my answer for the first part. Now for B part, I have to consider another complex number, and the cube roots of z2 by z1 are denoted by u, v, w, which we have to find. So what I can do is, for B part, first of all, I have to find what is z2 by z1. So I will write what is the values given to me. 5 pi by 6 whole divided by z1 value we just found out as minus I pi by 3. Now I can apply properties of complex number and write z2 by z1 as these two will get cancelled out and both I values will be subtracted. So minus I pi by 3. On simplifying, you can simplify by taking LCM as 6, so that becomes 5 pi plus 2 pi, which is e to the power I 7 pi by 6. So we found out z2 by z1 as e to the power I 7 pi by 6. But our question was to find u, v, w because these are the cube roots. For that, we have to write this in general form. So I can write it as, if I want to write this in general form, so I will take z2 by z1. So z2 by z1 will be 5 pi by 6 plus 2 pi k. Now I have to take different values of k. So first of all, I can take k as minus 1. So z2 by z1 for k is equals to minus 1 will become I 5 pi by 6 minus 2 pi. On simplification, you will get it as I 7 pi by 6 I. Now if I take k value as 0, so z2 by z1 becomes e to the power I 5 pi by 6 plus 0, which is nothing but 5 pi by 6 I. And now if I put k value as 1, so z2 by z1 becomes e to the power I 5 pi by 6 plus 2 pi, which on simplification will become 17 pi by 6 I. So one will become u, another v, and the last one w. So these are your answers. Next question is, we have to determine the value of this function. So first of all, let's start by putting x is equals to 0. So when we put x is equals to 0, put the limit. So it will be 0 into sine 0 upon 1 minus cos 0, which is nothing but 0 upon 0. So we got a form 0 upon 0. So now we can apply L'Hopital's rule. So L'Hopital says we have to differentiate numerator and denominator separately, but since we have x sine x in the numerator, so we have to apply product rule. So x as it is, sine x derivative becomes cos x plus sine x as it is, derivative of x becomes 1. Whole divided by 1 derivative is 0. Cos x derivative is minus sine x. Now if I want to further simplify this, so I can write it as x cos x plus sine x whole divided by sine x. Now I will try to put my limit again. So that will be 0 cos 0 plus sine 0 upon sine 0. Now by putting the limit, I am again getting 0 by 0 form. It means I have to again apply L'Hopital rule. This time I will be applying it in this. So on applying L'Hopital rule, again I have to write product rule in x cos x. So x derivative is 1, cos x remains the same. X becomes same and cos x derivative is minus sin x, plus sin x derivative becomes cos x. Whole divided by sin x derivative is cos x. Now if I put the limit, so it becomes cos 0 minus 0 into sin 0, I will put it into bracket, plus cos 0 whole divided by cos 0. Now as we know that cos 0 is 1, so 1 minus 0 plus 1 upon 1, that becomes 2. So 2 is my answer. You can also solve this method using rationalization. You can try rationalizing the denominator and then you will get to the same answer. Now in this question, we have the sequence. The first 3 terms of the sequence is given to me. For A part, we have to consider that this is arithmetic and we have to find value of k. So let's start. For k, since it is arithmetic value, it means common difference should be same. So we can write u2 minus u1, that is my common difference, is equals to u3 minus u2, that is also common difference. That gives me 3 minus 2k is u2, u1 is k minus 5, that is equals to 5k plus 3 minus 3 minus 2k. Now if I further simplify it, it becomes 3 minus 2k minus k plus 5 is equals to 5k plus 3 minus 3 plus 2k. Now on simplification, you will get k as 4 by 5. Now for the second part, it says we have to find u3. As you can see, u3 is equals to 5k plus 3. So we can substitute k value from first part as 4 by 5 and we will get, I will write u3 here, u3 as 4 plus 3, which is nothing but 7. Now for B part, we have to consider the case where k is equals to 12 and we have to find the first 3 terms of un. So let's start with the solution. So my u1 becomes 12 minus 5, which is 7. u2 becomes 3 minus 2 into 12, which is minus 21. And u3 becomes 5 into 12 plus 3, which is 63. So I got all first 3 terms. Now for the second part, it says consider this as geometric. Till the time we were in the A part, we were considering as arithmetic. So for B part, we are considering this as geometric. Now we have to state a reason why the sum of an infinite number of terms of this sequence does not exist. So what is important here to note is, for infinite number of terms, my R value should lie from minus 1 to 1. But since here you can see that your R value is greater than 1, so we can say that it is not convergent. Since it is not convergent, so sum of an infinite number of terms of this sequence does not exist. Now in this part, we have to show that k square minus 10k minus 24 equals to 0. But it says for the second value of k. So first of all, we have to find the second value of k. For that, since it is a geometric sequence, so I can write it as u3 by u2 is equals to u2 by u1. So my u3 was 3 minus 2k, k minus 5 is equals to 5k plus 3 upon 3 minus 2k. Now when we will solve this, it becomes 3 minus 2k whole square is equals to 5k plus 3 into k minus 5. Now I will apply a minus b whole square. So a square plus b square minus 2ab will give me this. I will open the brackets over here also, that is 5k square minus 25k plus 3k minus 15. Now on simplification, when you will simplify this further, I can write it as 12k plus 4k square minus 5k square plus 22k plus 15 is equals to 0. And on further simplification, we will get k square minus 10k minus 24 is equals to 0. So this is what we have to show in A part. Now let's move to the second part. Find the first three terms of un for this second value of k. Till now we have not found out the value of k. So we will use first part equation, that is k square minus 10k minus 24 is equals to 0. And when we will factorize, I am doing middle term splitting. So I can write minus 10k as minus 12k plus 2k minus 24 is equals to 0. Can take my k common, and from next two terms I can take 2 common. That becomes this. Now I can take k minus 12 entire common. So I will get this. Now either k minus 12 is equals to 0 or k plus 2 is equals to 0. It means k is either 12 or minus 2. Now k is equals to 12 value was already given to us in part B. It means this is our second value of k which the question is talking about. But we have to find first three terms. So my u1 becomes minus 7, u2 becomes 7, u3 becomes minus 7. So these are my first three terms of un. Now in the third part it says write down the value of S2m, where 2m is the sum of first 2m terms, and for this second value of k. Now what is important to note here is these are the three values when we have used the second value of k, that is minus 2. So to solve third part, we have to take sum of first two values, that is u1 plus u2, which is nothing but minus 7 plus 7, that becomes 0. So this is my answer for the third part. In this question we have 4 points a, b, c, d, out of which we have given the coordinates of a, b and c only, and it is a parallelogram where d is diagonally opposite to b. We have to find the coordinate of d. To find the coordinate of d, we know that diagonals bisect each other. I will write first for a parallelogram. So I can write that a plus c is equals to b plus d. So from here I can write d as a plus c minus b. So my d will become, a value is 1, minus 4 and 0, c is minus 1, minus 2 and 4, b is minus 3, minus 6 and 2. Now on simplifying this, we will get d as 3, 0 and 2, or I can write my coordinate as 3, 0, 2. Now for the b part, it says diagonal of the parallelogram AC and BD intersect at E. We have to find the coordinate of E. Now to solve b part, since they intersect, it means E is nothing but the midpoint of AC and BD. So we have A, B, C, D coordinates. So E will become the midpoint, that is, so we will apply x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 by 2. Now on simplification, we will get 0, minus 3, 2 as the coordinates of E. Now in this part we are given with AB cross AD as this. We have to find the value of M. Now to find the value of M, first we need to find what is AB and what is AD. So AB I can write as OB minus OA, that, and the coordinates are given to me in the question itself. This is for OB, O is origin and A is 1, minus 4 and 0. So from this AB coordinate comes out as minus 4, minus 2 and 2. Similarly, I will find AD coordinate as OD minus OA. I always do final minus initial. So OD is 1, 0, 2. This is the answer which we got from the A part. Minus OA is 1, minus 4 and 0, which will give me AD vector as 2, 4, 2. Now I have to do the cross product AB cross AD. So I will be using this it's a dot, which gives me minus 4, minus 2, 2, that is my AB vector value, and this is 2, 4, 2. Now to simplify this, I can write it as minus 4, minus 8. You can use your formula booklet. This expansion is given in that. Using that expansion, I can write my AB cross AD as this. Now on simplifying, I will get it as 12I plus 12J minus 12K. Now I have to write in this form to find M value. So I can write AB cross AD as minus 12, 12 and minus 12. I can take 12 common. I will get minus 1, 1 and minus 1. Now if you compare this with this given condition, so on comparison I can say M value is nothing but 12. Now we have to find the area of the parallelogram ABCD. So area is nothing but squares of the values which we got as I, J, K values. Minus 12 square plus 12 square minus 12 square. Now if you further simplify this, you will get 12 root 3 square units. So this is the area of parallelogram. Now moving on to the D part, the plane pi1 contains the parallelogram ABCD. We have to find Cartesian equation of pi. So it means we have to find the equation in x, y, z form. Now first of all, we have to note that normal vector to this plane pi1 is n, that we just found out the value as minus 1, 1 and minus 1. From C part 1 we just found out. Now we will be using point A coordinate as 1, minus 4 and 0, and we will be using point normal form of a plane. So what is point normal form of a plane? N dot r minus a is equals to 0, where n is nothing but normal, r will be x, y, z, since we have to write in Cartesian equation, and a is the coordinate of a point. So now if I simplify this, so I will write it like this: minus 1 x minus 1 plus 1 into y plus 4 minus 1 into z minus 0 is equals to 0. It gives me a solution like this. Now on further simplification, I can write it as Now I can take minus x common, minus common, or I can bring that 5 over there. So my Cartesian equation will be x minus y plus z is equals to 5. Now in this part we have another plane pi 2 having Cartesian equation like this. The acute angle between pi 1 and pi 2 is theta. Now we have to show that cos theta is 1 by 5. Now to solve this, first of all we need normal vectors which are n1. You can see from first part 1 minus 1 1, and n2 you can see from this Cartesian plane as 5 comma 1 comma minus 7. Now we have to find the angle, therefore we can use dot product. N1 dot N2 is equals to modulus N1 modulus N2 cos theta, and my N1 is 1 minus 1 1. I can do their dot product over here, 5 1 and minus 7 under root 1 square plus minus 1 square plus 1 square, and N2 is 5 square plus 1 square plus minus 7 square cos theta. Now after doing the dot product, I will get 5 minus 1 minus 7, and this will be root 3, this will be root 75 cos theta. Now I can rearrange and I can write my cos theta as 3 by 15, which gives me cos theta as 1 by 5. This is what we have to show in this part. Now in this part the line L passes through E and is perpendicular to plane pi 1, and line L intersects the plane pi 2 at point F, whose coordinate we have to find. Now first of all, since it says L passes through E, where my E coordinate was 0, minus 3 and 2, which I got from B part, I'll write it like this. Also, L is perpendicular to plane pi 1. So I can write direction vectors as 1 minus 1 1, which is from C first part I can take. Now I have to write parametric form. Parametric form you can check from in your formula booklet also, and I will write it here. So x, y, z is equals to 0, minus 3, 2, plus I will take variable as t, 1 minus 1 1. Now what I will do, I will substitute this value into my plane pi 2, which is nothing but 5x plus y minus 7z is equals to 1. And as it intersects the plane at F2, so what I can do is, I can write it as 5t plus minus 3 minus t minus 7, 2 plus t is equals to 1. Now you must be wondering from where I got this t, minus 3 minus t and 2 plus t. If you simplify this, you will get these three values. Now I will simplify it. So 5t minus 3 minus t minus 14 minus 7t is equals to 1. On further simplification, I can write it as this, which is nothing but 18. So from this I can write t as minus 6. But right now I have to find the coordinates of F. So to find the coordinates of F, I will use the parametric form and I will again write it, and here instead of t I will put minus 6. Now if you solve this, minus, we can write it as plus, minus 6, 6 and minus 6. You can also write this as 0, minus 3 and 2, plus minus 6, 6 and minus 6. It's completely your wish. So from this, coordinate of f is coming as minus 6, 3 and minus 4. So these are my coordinates. In this question, we have to consider the complex number z is equals to x plus yi such that modulus of z minus 2 plus I is equals to 3. And in A part, we have to show that this equation is equals to 0. So let's start. Now, since modulus z minus 2 plus I is given to as 3, so I will substitute z value as x plus yi. So it is modulus x plus yi minus 2 minus I is equals to 3. Now I will be separating real parts to one side and imaginary parts to other. I will get this equation. Now since it is in modulus, so to remove modulus we have to do squaring of x minus 2 and y minus 1, that is equals to 3. So now I can remove this under root sign and I can write it as 3 square. Now I will apply a minus b whole square. So a square plus b square minus 2ab. Again a square plus b square minus 2ab is equals to 9. Now I will rearrange this. X square plus y square minus 4x minus 2y plus 4 plus 1 minus 9 is equals to 0. So that gives me the final answer as x square plus y square minus 4x minus 2y minus 4 is equals to 0. This is what we have to show that in this part. Now in this part, z plus b upon z minus 1 argument is given to us as pi by 4. Now we have to show that this equation is equals to 0. So let's start. Since argument is given to us, so first I will write it like this, and I can use this as argument z plus p minus argument z minus 1. This is the property which you can find in your formula booklet. Now since z was given to me as x plus yi, so I can substitute it here in the right hand side and I can write it as x plus yi plus p minus argument x plus yi minus 1. Now again I will be simplifying real and imaginary part like this. I can put x plus p in bracket. Here also I will do the same thing. Now since we are talking about argument, so argument is nothing but arctan or tan inverse imaginary upon real. I can write the same for this also, arctan imaginary part upon real. Now we will use compound angle formula from the booklet for tan. So I can write it as tan arctan y upon x plus p minus again tan arctan y upon x minus 1. I will close this bracket also, whole divided by 1 plus again this into tan of arctan y upon x minus 1. So now tan, and since there is tan in arctan, so I can further simplify this and I can write it as y upon x plus p minus y upon x minus 1 whole divided by 1 plus y upon x plus p multiplied by y upon x minus 1. Now I will be taking LCM. So x plus p into x minus 1, I will further simplify this. X plus p, this is for the numerator, and for the denominator also I will take the LCM, x plus p and x minus 1. So this 1 will become x plus p into x minus 1 plus y into y is y square. Now in the starting of the question, it was given that this entire thing is equals to tan pi by 4 because the argument was equals to pi by 4. And we know that tan pi by 4 value is 1. So I can equate this to 1. And these two will get cancelled out. So I can write y into x minus 1 into y into x plus p whole divided by x minus 1 into x plus p plus y square is equals to 1. Now I will bring the denominator to the other side and I can simplify this minus yp, that is equals to x minus 1 into x plus p plus y square. Now these two will get cancelled out and I can write as minus y minus yp. I will open these brackets, x square plus xp minus x minus p plus y square. I will bring everything to right hand side. So I can get x square plus y square plus xp minus x minus p plus y plus yp is equals to 0. Now I can take x common. So that will be p minus 1 plus I can take y common from these two, 1 plus p, and I am left with minus b, that is equals to 0. This is what we have to show in this part. Now in this part it says two roots of this equation are z1 and z2, which we have already calculated. Both satisfies this condition and this condition. So we have to use the results from part A and B to find z1 and z2. So let's start with the solution. Since argument of z plus 4 upon z minus 1 is pi by 4, so from A and B part I can write both the equation, that is x square plus y square minus 4x minus 2y minus 4 equals to 0. This is my first equation. And the second one was x square plus y square plus p minus 1x plus p plus 1y minus p is equals to 0. Now from here you can see that these two are same if we compare both the equations, both the results from A and B. So I can say on comparing, after comparing, p becomes 4. Once I got my p value, now from B part I can write x square plus y square minus 4 minus 1, since I am substituting p value, minus p is equals to 0. So I will simplify this. I will get, I have to substitute p here also, 4 is equals to 0. I will name it as equation number 2. Now on solving equation 1 and 2, I can subtract this and I will get 7x minus 7y is equals to 0, which gives me, I can take 7 common. So x plus y is equals to 0, means x plus y is equals to 0 or x is equals to minus y. So this is one result which we got. Now what we can do is, we can put x is equals to minus y in my equation 1. So what I will get now, instead of y square, I can put as minus x square. So we can write y is equals to minus x also. So you can choose anyone. I am replacing y. So 4x minus, it was 2y minus 4 is equals to 0, which gives me 2x square minus 2x minus 4 is equals to 0. I can take out 2 common, so I can write this equation as this. Now on factorizing this equation, I will get x minus 2 and x plus 1. It means either x minus 2 is 0 or x plus 1 is 0. So I will get x as 2 and x as minus 1. These are the two values of x which I got. Now I am saying that x is equals to minus y or y is equals to minus x. Therefore, by putting the value of x in this, I will get my y value as minus 2 or 1. So we got our x and y both values. Now, if we take x as 2 and y as minus 2, so I can say that my z1 is 2 minus 2i, because in the starting of the question, z was x plus yi. Now, if I take x as minus 1 and y as 1, so I can write another value as minus 1 plus I. Now, these are the two roots which I got. Now, in the last part of the question, we have to find a. Now, how we will find a? In the earlier part, it was given that 4 roots are z1, z2, z3, z4. And from C part, we got 2 roots as z1 was 2 minus 2y. So and z2 was minus 1 plus I. So another root can be the complex conjugate, that is 2 plus 2i, and complex conjugate of z2. So these are the 4 roots which I got. Now for the given equation, z to the power 4 plus az cube plus bz square plus cz plus d is equals to 0. From the formula booklet, we can write the sum of roots as minus a. Now sum of the roots means I have to add all 4. So z1, z2, z3, z4, all my roots are being added. z1 is 2 minus 2i, z2 is minus 1 plus I, z3 is 2 plus 2i, and z4 is minus 1 minus I, that is equals to minus a. On solving this, we will get a as minus 2. Alright, that brings us to the end of this past year paper solution. If this solution helped you understand the concept and exam approach, do give the video a like. If you have any doubts or would like to see more IB past year questions, feel free to leave a comment below. Don't forget to subscribe to IB Methodology for more clear and exam focused IB content. Thank you for watching, and I'll see you in the next video.